Hello to students. In this video, let us discuss what is heat and what are heat capacities at constant pressure and at constant volume, Cp and Cv relation, etc. So first, let us come to which one here, heat. What is the definition of heat? Let us see here. Heat means what? It is a form of which one energy. So the energy transformation from one body to another body, which differ by temperature. That means from hot body to colder body, the energy which is transformed, also that energy is known as nothing but heat. So the energy transition from one body to another body which differ in temperature, that form of energy is nothing but known as which one? Heat. And what are the units of heat means? Calorie and joule. So both units are here, calorie and joule. 1 calorie equals to 4.18 joules. So we have to remember this, which one here, interrelation between calorie and joules. So the form of energy which can transformed from hotter body to colder body, that is said to be which one here? Heat. Okay, then let us define what is a calorie. What is a calorie means here the amount of heat required to raise the temperature of 1 gram of water by 1 degree. That means either degree centigrade or Kelvin, whatever it may be, by 1 degree centigrade present at 15 degree centigrade. So I repeat again this one. The amount of heat required to raise the temperature of 1 gram of water by 1 degree centigrade present at 15 degree centigrade. That means from 15 degree centigrade to, if you want to raise the temperature to 16 degree centigrade, because by 1 degree means here we have to add 15 plus 1, 16 degree centigrade. So how much amount of heat we need to supply? That amount of heat is nothing but said to be which one? Calorie. So the amount of heat required to raise the temperature of especially 1 gram of water by 1 degree centigrade present at 15 degree centigrade is known as a calorie. And SI unit for calories, which one means joule. SI unit for that heat is nothing but which one? Joule, not calorie. SI unit for heat is joule. So we have defined here calorie. Okay, now what is the relation between calorie and joule means? 1 calorie equals to 4.18 joules. Okay, now come to another one here. Another definition is which one means heat capacity. Heat capacity means what? Let us see here. Heat capacity means the amount of heat required to raise the temperature of any substance by 1 degree centigrade is known as which one? Heat capacity. The amount of heat energy required to raise the temperature of any substance. How much amount is not mandatory here? Any much amount of substance by 1 degree centigrade, from any temperature to 1 degree. That means from 90 degree centigrade to 91, or from 90 Kelvin to 91 Kelvin, whatever it may be. So now the amount of heat required to raise the temperature of a substance by 1 degree is known as which one? Means that heat capacity. So now heat capacity can be calculated like this here, dq by dt. That means amount of heat given divided by change in temperature. This is called which one? Heat capacity. And after heat capacity, let us go for another definition here. What is that means? Molar heat capacity. What is the definition of molar heat capacity? Let us see here. So, amount of heat required to raise the temperature of 1 mole of substance. In the previous case, amount is not mandatory. In which case? In heat capacity case. But in molar heat capacity, the name indicating that molar means it is related to 1 mole of substance. So now here the amount of heat required to raise the temperature of 1 mole of a substance again by 1 degree centigrade is known as molar heat capacity. So now another one here, what is that? Specific heat. Specific heat definition is what here? The amount of heat energy required to raise the temperature of 1 gram of substance by 1 degree centigrade is known as specific heat. So let us get the clarity. Calorie means the amount of heat required to raise the 1 gram of water here. Especially 1 gram of water we have to consider. But by 1 degree centigrade, that is common, is known as a calorie. 1 degree centigrade is common in all cases. But here what is the speciality? 1 gram of water, that is related to calorie. Next, heat capacity. Any amount of substance, if you want to raise the temperature of any amount of substance but 1 degree centigrade, here that is common, is known as heat capacity. And molar heat capacity means the amount of heat required to raise the temperature of 1 mole of substance again by 1 degree centigrade is known as molar heat capacity. And what is specific heat means? The amount of heat required to raise the temperature of 1 gram of substance by 1 degree centigrade is known as which one? Specific heat. So in all the 4 cases, the change in temperature is by 1 degree centigrade, that is common. But specific, that calorie means which one? 1 gram of water. Heat capacity means any amount of substance. Molar heat capacity means 1 mole of substance. And specific heat means 1 gram of substance. So the relation between molar heat capacity and specific heat. So molar heat capacity, if you want to calculate using specific heat, what we have to do here? Specific heat into molecular weight. Because specific heat related to 1 gram, if it is multiplied with its molecular weight, that equals to which one? Molar heat capacity. So now these are the definitions of which one? Heat, calorie, and molar heat capacity, specific heat, etc. Now one important formula I give here. If you want, you can note down it. What is that? Change in temperature. The questions we get like this, regarding which one? Change in temperature. They give which values here? They give molar heat capacity of a substance and how much heat given to that substance, that also they provide. We have to calculate which one? Change in temperature for a specific amount of that substance. Now what is the formula here? Means amount of heat given, Q means heat given to the substance, into molecular weight of the substance divided by molar heat capacity. Molar heat capacity into weight of the substance. Into weight of substance. By using this formula, we can calculate, but what is that? How by how much the change in temperature? So heat given to that substance into molecular weight of the substance divided by molar heat capacity into which one here? Weight of the substance. Let us see one question related to this one here. After that, we go for what is that heat capacity at constant pressure, at constant volume, Cp and Cv, and the relation between them. First, let us see one question related to this. Now, weight of which one we have to write here? Substance. Now, the first question here, what is that? Molar heat capacity. Molar heat capacity of water is 75 joule per degree per mole. Per degree per mole. So this is molar heat capacity. Now, how much heat we have given to that substance? Let us see here. Okay, now what is this formula here? Molecular weight divided by molar heat capacity. Molar heat capacity into weight of the substance. Weight of substance. So now come to this one. Molar heat capacity of water 75 joules. Now 1 kilojoule heat given to 100 gram of water. Now what is rising temperature? We have to calculate which one rising temperature. Now by using this formula, delta T equals to amount of heat given to that water is how much? 1 kilojoule. But here we have to take care something. See here, this molar heat capacity they have given in 75 joules they have given. But now this is given which one in kilojoules. So 1 kilojoule heat given to which 100 gram of water. So here this is given in kilojoules. So we have to maintain the same units. That means this kilojoules should be converted into which one here? Joules. So now tau Q means here we can get which one? 1000 joules. 1000 joules into what is the molecular weight of water means we know that 18 divided by molar heat capacity given how much means 75 given into weight of the substance is how much means 100. Okay, two zeros get cancelled here. Now 10 into 18 means we can get 180. 180 by 75. So we have to calculate that one. That means here, for suppose if 150 is there, we can write 150 ones. But 75 is there means 75 twos. And how much remaining there means 30. And upon calculation, you can get something 2.4 Kelvin or 2.4 like that. So this is the change in which one means temperature. Like that we can calculate. Now let us go for another question related to the same concept. What is another question? Let us see here. Now again, that molar heat capacity. Molar heat capacity of water is 18, but this time I'm giving in which one? Calories. So 18 calorie per degree Kelvin per mole. And now the heat energy required, the heat energy required to raise the temperature of which one? 18 gram of water is 18 gram of water by 0.2 degree Kelvin is x calories. Is which one? X calories. Now in these two questions are there. First we have to find out which one? X calories. And another question same related to this one. What is another question here? Now methane heat of combustion value is minus 200 joules. what is the amount of methane required to produce this X calories? Okay, now take it which one here? Minus 200 calories only. Okay, now what is the amount of methane required to produce that X calories heat energy? So now first let us go for the first question here. What is that one? We have to calculate which one heat required, we have to calculate. So what is our formula here? That delta T means here the change in temperature is how much? 0.2 equals to Q we need to determine, and molecular weight of water is 18, and heat molar heat capacity of water, molar heat capacity of water, okay, that is also which one here they have given? 18. So 18 into weight of water is 18. So 18 ones are 18 ones are get cancelled. Now Q equals to 0.2 into 18 calories. So this much amount of heat we need to provide for this water. Now this is the first question answer. Now what is the second question? They have given methane, that heat of combustion of methane is they have given 200 calories. Now what is the amount of methane required to produce this much of heat energy? So heat of combustion of methane means what here? 16 gram of methane produces 200 calorie heat energy. Therefore, how many gram of methane should produce this 0.2 into 18 calories energy? Therefore, that weight or amount of methane equals to what we have to do here? 0.2 into 18 by 200 into which one? 16. So now upon calculation here you get which one? That answer. That means here this can be written as which one? 2 into 18 into 16 into 10 power minus 1 divided by 2 into 10 power 2. 2 and 2 get cancelled. 10 power 2 when comes to the numerator become 10 power minus 2. Therefore, we can get this answer here: 18 into 16 into 10 power minus 3. So, this is the amount of which one? Methane required to get that heat energy. So these are the different type of questions related to which one? Heat capacity, specific heat, and molar heat capacity, etc. Now let us go for another question here. For example, molar heat capacity of methane, molar heat capacity, molar heat capacity of methane is, for example, they have given 32 calorie per degree Kelvin per mole. Therefore, now the question is here, what is the that which one? Amount of heat, what is amount of heat required to raise the temperature of 8 gram of methane, 8 gram methane by 2 degrees centigrade? So if that question is given, so we have to calculate which one here, what is the amount of heat now. And of course here what they have given? Molar heat capacity also. Now delta T means here how much? 2 degrees centigrade, or change in temperature 2 degrees. So therefore 2 equals to, we need to calculate Q into molecular weight of methane 16 divided by molar heat capacity is 32. 32 into weight of methane is given 8. So now 16 ones are 16 twos are, therefore Q equals to 32. So this is which one here? 32 calories. By giving that much heat, we can raise the temperature of 8 gram of that methane by how many degrees centigrade, means 2 degrees centigrade. So these are the different questions we have to solve from this topic. Okay, then what is that need of Cp and Cv? Let us see here. What is the need means here? Heat capacity is given as which one here? dq by dt, and as heat is not a state function, so that heat capacity also not a state function. So we need some terms here at constant volume and at constant pressure to express its value. So now heat capacity at constant volume is known as Cv. Heat capacity at constant pressure is known as Cp. So what is Cv means here? That is nothing but change in internal energy at constant temperature. So that dE by dt. And heat capacity at constant pressure is nothing but change in enthalpy at a constant temperature. So these are the expressions for heat capacity at constant volume, heat capacity at constant pressure. Now let us derive the relation between which one, Cp and Cv. So now what is that? We know that already H equals to E plus Pv. Therefore dH equals to dE plus Pdv. Dividing this equation both sides with dt, now we can get dH by dt equals to dE by dt Pdv by dt. And we know that Pv equals to, for 1 mole of gas, RT. By substituting here, dH by dt equals to dE by dt plus RdT by dt. dt get cancelled. Now this can be written as Cp, this can be written as Cv plus R. That means Cp minus Cv equals to R. So this is the derivation of Cp minus Cv equals to R expression. And one more important thing related to Cp and Cv. What is that important thing? Means ratio. Ratio between Cp and Cv. Cp Cv ratio is known as Poisson's ratio. Now this is indicated with gamma. For monoatomic gases, gamma is 1.66. For diatomic gases, gamma is 1.4. Okay, for polyatomic gases, gamma value is 1.33. So we have to remember those gamma values. So this is regarding which one? Heat capacity, molar heat capacity, specific heat calorie. Okay, in our next video, let us discuss which one? Heat of reaction. What is standard heat of reaction? Bye.